Hello, everybody. So, in the last video, we created a random 3D map using some randomized boxes and cylinders. Now, we all have also imported a capsule as our player, but we haven't coded the movement of our player. Now, in today's video, we will see how we can create a capsule player and we will also write the code. Now, we have already done this in 2D. In 2D, it's very simple because in 2D, our player is nothing but some pixels. However, in 3D, it is little bit tricky, but not at all difficult. And we will see today how we can do this. So let me close this scene. And here I have removed the capsule, but we have our world. So if we run once again, we will have a random world. Every time a new world will be generated. Now, to create our player, what we have to do is, as usual, we have to create a new scene. And in place of scene, I will take the character body 3D. For pixel art, we take 2D. Here we will take the 3D one. Next, we will add a mesh instance 3D. So we'll search for it and we got a mesh instance 3D. And after the mesh instance, we have to add a collision. And also, as we can see, there is an error and it is saying that this node has no shape, so it cannot collide. So this is a standard error and we also get this in 2D. Now, what is a mesh instance? A mesh instance can select a mesh. So before we add the collision, we need to have a mesh. So we will add a capsule mesh. Now, generally, we can experiment using circles or boxes, but that is for our 2D. In 3D, we generally take the shape of a circle. And for any player, a circle shape is the most appropriate shape to represent any complex shape. So generally, we take it. It's good for many things. Now, let me also give it a color. So in the geometry, I will add a material, new standard material. And if you remember in the last video, we were doing all of these things using our code. And here we used to add something called an albedo color. So we will click on the material, there is an albedo, and here we will give an orangish color. So let me give it a color like this. Yeah. So we have our player. Now next thing is we have to add a collision. So we'll add a collision shape 3D. And the shape will be basically our capsule shape. And it is exactly the size of our player, which is fine. Next, we have to add something called a pivot. So in 2D, we do something that is we place a camera focusing on our player from the top-down view. So as our player moves, the camera also moves and we move through the map. Now in 3D, the movement is a little bit complex. So we have our player movement as well as we have our camera movement. So if you have played Pokemon Sun and Moon and many other games for that matter, we have a player movement. We can move our mouse and move our player, but also we can move our camera in many situations. So we will need a pivot. So around the pivot, our camera will be moving. So there will be a logic for our player movement and our camera movement will be using our mouse. So key press for our player movement, mouse press for our camera movement. This is not required for 2D. And this is where 3D becomes a little bit tricky, but this is also very simple. So there is no need to worry. Let me just show you how to do this. So we will just add a node 3D and I will name it as pivot. So in the pivots, we will add a spring arm. And as a child of the spring arm, I will add a camera 3D. Now, right now, this camera is placed here. So if you see, this is where the camera is placed. So what I will do is I will move the camera. So this is the move tool. So W and E for the rotate and R for the scale. Little bit odd selections. Now in Blender, this is more simple. Grab tool, G, S, and R. But yeah, we can also set these buttons. But yeah, for now we can simply use these tools. We will not be doing that much modeling in Godot. We will mostly be importing models from Blender. So it's not a big deal, I will say. So we got whatever we want. So we will place the camera here for now. Let me add a little bit of rotation, something like this. And maybe it can move a little bit up, something like this. And we need to save this scene, of course. So in our scene, so let me change this to capsule or player capsule. We can add other players also later. So for this reason, let's add a capsule into our scenes. So let's save it here. And now in our scripts, we have a world3d.gd. Uh, we all have this script. We have written the script in the last episode. So what we need to do is we have to add a capsule script. So in the capsule, I will add the script and let me save it in the scripts folder. So capsule.gd. And here, this is a node default. We can also have a basic 3D movement, but I will use the default for now. So let me just create it. So it extends a character body 3D because our parent is character body 3D. And here we will start by defining a speed. Let's call it 5.0. And then let's also do a jump velocity as 10.0. Now 10 is our gravity, 9.8 to be more precise, but we will just keep 10. And we need few variables. So one is our pivot. So this is our pivot. And also, whenever we are moving our camera, we have to take care of something called sensitivity. So we will add another variable called sensitivity. This will be 0.5 for now. Now in our ready function, what we need to do is we need to take care of our mouse mode. So we'll do a mouse mode equals to input dot mouse mode captured. So because using our mouse, we will be moving our camera and our exit button will also be with our mouse. So we will have to take care of the mouse mode in the ready. Now we will write another function and we all know this function. This is called physics process. This is a standard function. So here, what we need to do is basically we have to take care of our movements. So we will first do this thing. If input dot is action just pressed, and if I press the button UI accept, so this is ideally our enter or our space bar. And we also need to check one more thing, that our player is right now in the floor. So if our player is in the sky and they are pressing spacebar, they should not be able to jump. So this is for checking our jump. So is on floor. If both of these things are true, what we will do is velocity.y, we will set it to jump velocity, basically 10. Now this velocity comes by default. We don't need to add it. We also know this thing. This is present in the 2D also. So there will be many things in common with 2D, but some of the things will be a little bit tricky, like this camera movement, etc., etc. But yeah, so this part I believe is clear now. We have to press spacebar. We can also add another button. That's fine. We will add spacebar for now. And if our player is on the floor, then we will basically jump. Now, what happens if our player is not on the floor? So we have to add that condition also. If not is on floor, in that case, we have to come down. So velocity plus equals to get gravity times the delta. Delta is something we are getting inside the function, which is basically the time interval passed. So we have these things here. Now the next thing is we have to get an input direction. So we'll do input direction. And this will be basically our input dot get vector. And here what we will do is we will check that which direction we are moving. So we are moving left or right or forward or backward. And accordingly, we will get a vector and we will save it inside our input direction. So what we will do is we will, in our project settings, in our input map, we will add some actions. So right now, um, if I click on show built-in actions, so these are all our actions. So UI accept is basically enter or spacebar, etc., etc. What I want to do is I want to add some new actions. So let me just close it here and let me write move left. And if I click on plus add, so we got something called move left. Now, what is a move left? So move left, whenever we press a button, we want to move left. So in our keyboard keys, uh, Let me press A. So is there A? There should be an A. So A or A physical, so something will come by default. So that is what we need to select. So if I write A, so A or A physical or whatever is that. So whenever we press A, so we are basically selecting WSAD. So we will trigger the event move left. So that is what we want to set basically. So then we will set move right. We have added it and we'll just click on D and it will come by default. We can also search it. So here, as you can see, physical key, code, position, I mean, whatever. So it will come by default. So it's gone on once again. So D. So D. So move right is D. Now, left, right, then forward and backward. That will be W and S. So let me give move forward. This will be W and then move backward. This will be what? This will be S. And we will also add one more thing, and that is a quit. So quit will be what we call escape. So whenever we press escape, we should be able to quit the game. Because what happens is, I will show you, in 3D, whenever we launch the game like this, we will not be having access to our cursor. So closing the game might be a little bit tricky in that sense. Like it's another story. So it's better we get the access of our mouse or we can close the game directly. Now, we want to get input direction. So here we will give move left, comma, move right, then move forward and move backward. Now we will add a direction. So we already got an input direction, which is a set of keys. Now we need to add the mathematical direction to change our speed and our position. So we'll get it by transform basis times vector 3. And here we will check the input direction dot x comma 0 because these are our lateral directions, and then the input dir dot y because in our viewport the y is a vertical direction, but in the vector 3D the third one is our vertical dot normalized so that it becomes 1 and minus 1, that can be used to change the directions. Now if we have a direction, we need to change the speed accordingly. So velocity dot x equals to whatever direction we get dot x times the speed, and the velocity dot z equals to again whatever direction we get times this speed. Um, and when we don't have a direction, we need to basically move our player. So velocity dot x, so we will move our player by that much equals to move toward, and we need to pass our velocity dot x comma. So as you can see here we have the things that we are passing. So from to, and the delta, so by how much is our speed. Similarly for the z also, velocity dot z equals to move toward. So from velocity dot z to 0, and the interval is speed. And lastly we'll do a move and slide. This is what we do for our 2D also. And one more thing that needs to be added is our exit condition. So if input dot is action just pressed, if it is quit, in that case input dot mouse mode, input dot mouse mode visible. Now I will show you what this means. So let me just start the game. Not here. So as you can see, we lost our mouse cursor. So this is a problem. So how can we close it? We have to close it using our task manager or some other way that we need to find. But now if we simply press escape, we will get back our cursor and we can simply close it like this. So this is what our quit button is doing. So this is really helpful. So one more problem that we can see is that the size of our player is very big. So what we can do simply is make the size smaller. So here, this is our scale. So E. So E and not E. The scale is basically R, and E is our rotation. So let's make it smaller. So this is much smaller, and so we have to make our collision smaller also. So collision will be small like this. So now let me run once again, and now I think this is much better. Okay. So what we need to do now in our world scene, let me remove the camera. This camera is basically for showing the world in this way. We can remove it because we will be adding our capsule. So in our link, we'll add a capsule. And now if we run our world, we have something and we can see our capsule is also moving and also jumping. So we already have a player and this looks fantastic, I will say. We also have a sun and we have a beautiful city. But we are moving our mouse and we are not able to change directions. So it is moving in a strange way. Now we generally don't move like this whenever we have a capsule, or we also don't move backward like this. So backward movement will be there. But what we generally do is using our mouse, we change the direction, like the movement, the face of our player, and we move accordingly. So that is our camera movement also. So we need to take care of that. So how we can do that is what we will see now. So let's get back to the script once again. So we have our regular movements. Now we need to add our camera movement, and then this will be done. So we need to add another function. So func input. This is also a regular input. So regular function. So we need to check if the event is there, and if the event is input event mouse motion. So if we are moving the mouse is what we are checking. We need to rotate the Y direction, and we'll change degree to radian minus event dot relative x plus sensitivity. So basically in the Y direction, um, we are moving our mouse by the value of sensitivity. So whenever we have a mouse motion, it will not be a single event, it will be multiple events triggering together. So in every event, we will be moving it by sensitivity. Now what does this mean? This will have little bit of a change, not much. So if we run the world once again, so as you can see, we can move laterally. We cannot move up and down as of now, but the lateral movement is there, and this is already good, I will say. This is already good. Um, but modern games should also have up and down movement. So let's see how we can add that one. Now, what will happen if the sensitivity becomes much larger? Let's say 5. What will happen in that case? So as you can see, um, the speed is very high. So which could be a problem. And if it is very low, what will happen? Let's say 0.05. So very small sensitivity is not much of a problem. But here, as you can see, there are some issues. Now, this I don't think this is a regular issue. So if we just so as you can see, small values are not that much of a problem, but whenever the value is big, it will be adding it by a large value. So what we will do is we will just make it zero point 0.2 or something like that. So zero point 0.2 or zero point 0.3. These things are not much. Now for the up and down movement, we have to rotate in the x direction. Now, this rotation will be actually on the pivot. So we'll do a pivot dot rotate x. And how much do we should allow the rotation? I don't think we should allow any rotation. We should have a limitation on that. So what we will do is degree to radian and minus event dot relative dot y uh, times sensitivity. So this is how much we are giving, and then the pivot dot rotation dot x. Here what we will do is we will clamp it to some particular value. So in the horizontal we can move 360 degrees, but in the vertical we shouldn't allow 360 degree. There should be a limitation. So whatever limitation is there, that should be in the clamp. So I believe the limitation should be something like clamp dot rotation dot x, comma, degree to radian, and the rotation will be something like minus 90. So we can move to 90 degree at the top to something like 90 degree at the bottom. So this one, degree to radian 90, comma, degree to radian 90. So from minus 90 to plus 90, this will be, so basically 180 degree is what we are allowing in the vertical direction. So now, okay, so there is a problem. So there is a spelling mistake here. So that is the problem. Now let me run once again. So here, horizontally, everything is fine. So vertically, this is minus 90 and this is plus 90. I think this is too much. We shouldn't allow this much. I think it should be from minus 60 to plus 60. And as you can see, we can also see the sun. I think this is not half bad, but yeah, I think this is too much. So this should be minus 60 to plus 60. Now let me run once again. And this one, the bottom view, we can also see the sun, like we can take a glimpse of the sun, and this is the top view. So, and our movement will work perfectly fine. So yeah, we got a very simple character movement, and we can also have more complex movements, especially in action games. We have crawl, sleep, whatever, crouch, many other kinds of things. And the world of 3D is vast, even more than 2D, I will say. So yeah, gradually we will make more games and more scenes like this, and we'll see what more things we can do. So yeah, that's it for this video, folks. And if you have learned something new in this video, make sure to like, share, and subscribe the channel to help me grow it fast. And I will see you soon with another very interesting video. So see ya.